Let's look at this question. Okay, a wheel rotates around a stationary axis so that the rotation angle varies with time t as pi is equals to 80 square. So what is happening in the question is there is a wheel. Okay, this is the axis of rotation. The axis of rotation is in z direction. Okay, suppose the wheel is rotating with angular velocity omega. The angular displacement is given by the relation phi is equals to 80 square. See, phi is equals to 80 square. Okay. Now what is the how do I find out the angular velocity? See, whatever relations are valid in linear motion or linear mechanics, the same relations are valid in rotational mechanics. That means in linear mechanics, what was that? V is equals to ds by dt and A is equals to dv by dt. Similarly, in rotational mechanics, what will happen is angular velocity is equals to d phi by dt or angular rate of angular displacement by time, and angular acceleration is equals to d omega by dt. Okay, so we're going to use the relation, these two relation to solve the question. So the angular velocity is equals to d phi by dt is equals to 2at, and out here angular acceleration is equals to d omega by dt, which is equals to 2a. So the acceleration, angular acceleration is given by 2a. Okay, so at certain time, okay, find the total acceleration omega at point A, at rim, at t is equals to 2.5, with the linear velocity of point A at that moment is 0.65. So at point A in the rim, okay, let this be point A in the rim. The velocity is given by how much? 0.65. And in every circular motion, there are two acceleration. One of them is tangential acceleration, and the other one is centripetal acceleration or radial acceleration. And total acceleration is equals to vector sum of tangential acceleration plus centripetal acceleration, okay, or magnitude of total acceleration. Okay, okay. Now, how do I find out the tangential acceleration? See out here, we know the relation between, in the previous slide I have given angular displacement or linear displacement is equals to angular displacement into radius, linear velocity is equals to angular velocity into radius, and linear acceleration is equals to angular acceleration into radius. So the linear acceleration of this point is 0.65 meter per second. Okay, meter per second. So the relation between v is equals to omega r. Okay, Asha, what is the value of omega? The value of omega is nothing but 280. Okay, 280, and v is given in the question. V is given in the question. I have to find out r. When I find out r, see, the purpose of finding out r is tangential acceleration I can find out. Okay, tangential acceleration is nothing but acha, tangential acceleration. Acha, let's focus on r right now. Okay, we'll get to tangential acceleration little bit later. So v is equals to 0.65 is equals to 2 into what is the value of a? The value of a is nothing but 0.2 radians per second square. So 2 into 0.2 into what is time? Time is nothing but 2.5. So into 2.5 into r. So the value of r is nothing but 0.65 divided by 2 into 0.2 into 2.5 is equals to r. 2 into 0.2 to 2.5 is equals to r. Or the value of r becomes how much? 1 meter. R is equals to 1 meter. So the radius of this wheel is how much? 1 meter. Radius of this wheel is 1 meter. Now the next part of the problem. What is the value of this tangential acceleration? See, there is a relation between tangential acceleration and angular acceleration. tangential acceleration is equals to how much? Alpha into r. There are three relations. Linear displacement is equals to theta into r. Linear velocity is equals to omega r. Linear acceleration or tangential acceleration is equals to alpha into r. Okay, or at is equals to what is the value of alpha? The value of alpha is nothing but 2a. Okay, so value of alpha is 2 into a into r. Okay, or tangential acceleration is equals to 2 into what is the value of a? 0.2. What is the value of r? 1. Or tangential acceleration is equals to 0.4 meter per second square. So the value of tangential acceleration is equals to 0.4 meter per second square. Okay. Now what is the value of centripetal acceleration? Centripetal acceleration or radial acceleration is given by v square by r. Okay. Or centripetal acceleration is equals to what is the value of v? 0.65 square divided by r 1. Okay, the value of centripetal acceleration is equals to 0.65 square divided by 1 is meter per second. So therefore total acceleration is equals to under root of tangential acceleration square 0.4 square plus 0.65 square under root, which should be equals to which is equals to 0.7632 meter per second square. Okay. Okay. So before solving this question, we'll understand a little bit about how gun works. Okay. So gun is basically a barrel. Okay. And a bullet is kept out here. Okay. And when the trigger is pulled, you know what happens? Out here inside the gun, there is a lot of explosive. Okay. A pin strikes, a explosive burst out here. And I'm drawing the diagram of this barrel in a simplified manner. Okay. So I'm just drawing the barrel out here. Barrel of the gun. That means this much portion of the gun is drawn out here. Okay. So when the trigger is pulled, what happens? The explosives inside the bullet bursts open or bursts out. And what happens? Gases are released out here. And these gases are in very high pressurized gas. Okay. And these gases pushes the bullet out. Okay. And the bullet moves out of the barrel. Okay. With some velocity. Okay. Now in atmosphere, there is a lot of air. So air will be pushing down the bullet, slowing its velocity. So this atmospheric air causes a lot of inaccuracy of the bullet. To solve that, what the engineers did was they rotated the bullet. That means what the engineers did was, along with the forward velocity, there are some grooves made in the barrel. Okay, the purpose of these grooves is to rotate the bullet. So when the bullet comes out, the bullet also rotates with some angular velocity omega. Okay, bullet already has a translation velocity of v. This is around 800 meter per second to something around like that. Okay, sorry, 800 kilometer per hour or something like that. But it also rotates with some angular velocity, and this angular velocity is given to improve the accuracy of the bullet. And how is the angular velocity given? This angular velocity is given by making grooves inside the barrel of the gun. Inside the barrel of the gun. Understood this much? Okay. Now second thing to think out here. These gases are pushing out the bullet. So out here when the bullet was out there, what is the velocity of the bullet? 0 before firing. As the gases explode, the bullet will accelerate from head to head, no? Okay. And as soon as it comes out of the barrel, there is nothing to push out the bullet. Okay. So out here the acceleration will stop and the bullet will start moving with constant velocity. So the bullet started acceleration out here. Okay. And the acceleration stops out here. Okay. and after this the bullet starts moving with constant velocity. The velocity of the bullet was out here 0, the velocity of the bullet out here is v. So velocity is equals to 0 out here, velocity is equals to v out here. Acceleration is has some value throughout this, okay, and acceleration is equals to 0 as soon as the bullet comes out of the barrel. Now the third point, okay, since this bullet is also rotating, okay, the rotational velocity of the bullet before firing was 0, okay. Now how is the bullet rotating? The bullet is rotating by the grooves inside the barrel, no? Okay, so out here the bullet will have some angular velocity, okay. So angular velocity outside the barrel is equals to omega. So there is some angular acceleration plus linear acceleration of the bullet. That is basically what the question is saying. Okay, now let's read the question again. Let's rub this entire thing and read the question again. Okay, there is a barrel out here. I'm just drawing the barrel of the gun. Okay, the shell acquires the initial velocity of 320 meter per second. That means the bullet after ejection, the velocity of the bullet after ejection is how much? 320 meter per second, or velocity is equals to 320 meter per second. Velocity is equals to 320 meter per second. Having made 2 turns inside the barrel, that means the number of turns made by the bullet inside the barrel is equals to 2. Okay, 2 turns inside barrel. Turns inside barrel. Okay, because due to grooves of the barrel. Okay, the length of the barrel is equals to 2 meter. Okay, this is a very lengthy gun. Okay, assuming the shell moves inside the barrel with uniform acceleration, find out the angular velocity of its axial rotation at the moment when the shell escapes the barrel. Okay, so it turns around this axis with omega. Okay, find the angular velocity. I have to find out this angular velocity omega. What's the angular velocity out here? Angular velocity is equals to 0. Okay, what's the linear velocity? Linear velocity of the bullet inside the barrel before firing is also 0. Okay, now assuming acceleration, both linear acceleration and angular acceleration of the bullet. See, this is the bullet. Assuming both linear acceleration and angular acceleration of the bullet inside the barrel is constant. Okay, we have to find out the angular velocity of the bullet after it comes out of the barrel. Now you understood the question. Okay, so now let's solve it. Okay, out here constant acceleration is given. So out here, what is the formula you use whenever there is constant acceleration? So whenever there is constant acceleration, there are 3 formulas. Okay, first formula is how much? V is equals to u plus at. Second formula is s is equals to ut plus half at square. And the third formula is v square is equals to u square plus 2as. And the rotational equivalent are final angular velocity is equals to initial angular velocity plus alpha t. Okay, theta is equals to initial angular velocity t plus half angular acceleration t square. And the third formula is omega final square is equals to omega initial square plus 2 alpha theta. These are the formulas for constant angular acceleration and constant linear acceleration. So how do I approach from the outlet? Okay, the initial velocity is 0, final velocity is 320 meter per second. So can I apply v square is equals to u square plus 2as? I need to find out the time. What I'm approaching out here is I'm finding out the time taken to reach the bullet from head to head. Okay, and the time it took for the bullet to reach from head to head is exactly the time it took for the bullet to rotate 2 times. Understood? Okay, the bullet rotated inside the barrel 2 times. So the time it taken for to rotate the barrel inside the barrel 2 times is equals to time taken for the bullet to translate from here to here. Understood? This is the thing that I'm going for. So I'm going for the common thing out here is time. Time is common for both. Common for both. That means time taken for the bullet to travel 2 meters is equals to time taken for the bullet to turn 2 times or rotate 2 times. Understood? Okay. Now let's solve translation part. Translation motion. Translation motion means straight line motion. Okay. So I'm using v square is equals to u square plus 2s. I'm using this formula. V square is equals to u square plus 2s. Okay. What is the final velocity? 320. What is the initial velocity? 0. What is acceleration? I don't know. What is the distance? Distance is nothing but 2 meters. Okay. So 2. When we solve this one, we get the value of A to be 25600 meter per second square. So the linear acceleration is 25600 meter per second square. Now my question is, what is the time taken for the bullet to travel from here to here? For that we use this relation, v is equals to u plus at. So using v is equals to u plus at, we get the time. So velocity is equals to 320. Initial velocity is equals to 0. Acceleration is equals to 25600. We get the value of time. Or time is equals to 0.125 second. Okay. Sorry, 0.0125 seconds. I missed 10. 0.0125 second. Yes. Now we'll continue with rotational motion. Okay. So time is equals to how much? 0.0125 second. Okay. So now let's erase this one. And now let's focus on rotational motion. Okay. Rotational motion. Okay. What's the final angular velocity? I don't know. What's the initial angular velocity? We have to find out. So initial angular velocity is equals to 0. Okay, I know that time. So can I use this formula? Omega final is equals to omega initial plus alpha t. But problem is I don't know the value of alpha. So I'm using the second equation. Theta is equals to omega initial t plus half alpha t square. So instead of this equation, I'm using the second equation. Theta is equals to omega initial t plus half alpha t square. Okay, what is omega initial? Omega initial is equals to 0, or theta is equals to half alpha t square. What's the value of theta? The value of theta is nothing but 2 pi. 2 pi into 2. Why? The bullet turned 2 times inside the barrel, no? Okay, and what is one turn inside? What one turn in terms of radians? Whole one turn is nothing but 2 pi. So 2 turns is equals to 2 into 2 pi. 2 into 2 pi, or is equals to 4 pi. I don't know the angular acceleration, but I do know my time is equals to 0.0125. So therefore, the angular acceleration from this equation will turn out to be is equals to 160,849.54 radians per second square. Okay. Now I got the angular acceleration of the bullet. Okay. From the angular acceleration of the bullet, can I find out the final velocity using this formula? Omega final is equals to omega initial plus alpha t. So omega final is equals to omega initial plus alpha into t. But omega final, I need to find out omega initial is equals to 0. Alpha is equals to how much? 160,849.54. And time is equals to how much? 0.0125 second. Okay, so let's multiply this, or omega final is equals to 2010.6192 radians per second. Okay, now let's look at this question. Okay, a solid body rotates about the stationary axis according to the law phi is equals to 80 minus bt cube. That means angular displacement phi is given as 80 minus bt cube. Okay, okay. Find the mean value of angular velocity and angular acceleration averaged over the time interval between t is equals to 0 and complete stop. So I need to find out what average angular velocity. Average angular velocity. Achha, in linear mechanics, what is the formula for average velocity? That was total displacement by total time. Similarly, average angular velocity would be total angular displacement divided by total time. And total angular displacement is nothing but final angular position minus initial angular position divided by total time. Is this much correct? Okay. So out here, average angular velocity. Okay. Problem is, what is final angular velocity and initial angular velocity? Okay. So our initial is at time t is equals to 0. Okay. So at time t is equals to 0, when you put this value t is equals to 0 at this equation, okay, or at this equation, what do we get? We get theta I, or initial angular position, is equals to 0. Okay. Okay. Now problem is averaged over the time interval between t is equals to 0 and the complete stop. How do I find out when did the body stop completely? A body stops completely when the velocity is equals to 0. So out here, final angular velocity is equals to 0. Okay. Problem is, how do I find out when is the angular velocity 0? Let's look at this equation. This is the formula for angular displacement given in the question. No, how do I find velocity from displacement? We simply know that d phi by dt would give us the equation for angular velocity, or angular velocity is equals to a minus 3b t square. I just differentiated this term with respect to time to get the angular velocity. Okay. And how do I know when the particle stops? The particle stops when angular velocity is equals to 0. At omega is equals to 0, the particle will stop. So by solving this equation, I'll get 0 is equals to a minus 3bt square. Okay, a particle always stops when the angular velocity, or the, see, if a particle is moving in a straight line, okay, the particle will stop when the linear velocity is 0. If the particle is rotating, the rotation will stop when angular velocity is equals to 0. That means a particle stops when velocity is equals to 0. Okay, so out here from this equation, I'll get a is equals to 3bt square. Okay, Asha, let's solve this equation out here only. 0 is equals to a minus 3bt. Can I take this a to the left hand side? If I take this a to the left hand side, it will become a is equals to 3bt square. Can I take this 3b down out here? So a by 3b is equals to t square, or under root of a by 3b is equals to t, or t is equals to a by 3b, or a by 3b is equals to t. Okay, a by 3b is equals to t. Now I find out the time at which the particle stops completely. So t final is equals to under root of a by 3b. Okay, so out here time final is nothing but under root of a by 3b minus 0. So out here, time final becomes under root of a by 3b minus 0, or t final minus t initial. Problem is, how do I find out the final angular displacement? Theta final is equals to, I have to plug in the value of t in this equation. If I plug in the value of t in this equation, what do I get? I get the final angular position when the particle stops completely. Okay, so a into under root of a by 3b minus b into under root of a by 3b whole cube. Whole cube. Now, instead of writing under root of, can I write to the power 1 by 2? I'm cutting under root and writing to the power 1 by 2. I'm cutting the under root and writing power 1 by 2. Now, can I take a by 3b common, or a by 3b under to the power 1 by 2 common? Or theta final is equals to a by 3b to the power 1 by 2. I'm taking this entire thing common. A minus b to the power a by 3b. This was nothing but 3 by 2, and I took 1 by 2 common. So 3 by 2 minus 1 by 2 is nothing but 2 by 2, and 2 by 2 is nothing but 1. Okay, so this is our equation. Theta final is equals to a by 3b to the power 1 by 2. Out here b and b would get cancelled. Okay, so out here b and b is getting cancelled. So a minus a by 3 is nothing but 2a by 3. Okay, a minus a by 3, see out here, a minus a by 3 is nothing but 2a by 3. So 2a by 3. Okay, let's write this neatly out here. 2a by 3. Okay, so a to the power 3, a by 3b to the power 1 by 2 into 2a by 3 is the final angular displacement. Now can I substitute final angular displacement out here? And initial angular displacement is nothing but 0, and total time is nothing but this value. So I get average angular velocity. This symbol is nothing but out here, what this symbol is nothing but average angular velocity. Okay, is equals to theta final. What is theta final? A by 3b to the power 1 by 2 into 2a by 3 minus theta initial. Theta initial is nothing but 0. How do I find it out? See, when you put 0 at this equation, you get theta initial is equals to 0. Total time is equals to a by 3b to the power 1 by 2. A by 3b to the power 1 by 2. Now when I cancel this out, see, anything minus 0 would become 0. Sorry, anything minus 0 would be that value. Asha, can I cancel this out? A by 3b to the power 1 by 2, a by 3 to the power 1 by 2. So I'm cancelling this out. Okay. Asha, this is not to the power 0. This 0 came from this omega. Okay. So not confuse this 0 to the power 0. Okay. So average angular velocity is nothing but 2a by 3. Average angular velocity is nothing but 2a by 3. Okay. The second part of the question is the average angular acceleration. Okay. From kinematics, what is the value of angular acceleration or average acceleration? Average acceleration was nothing but total change in velocity divided by total time, or final velocity minus initial velocity divided by total time. So average angular acceleration would also be the same. Final angular velocity minus initial angular velocity divided by total time. Okay, average velocity is total displacement by total time, or final displacement minus initial displacement by total time, or final position minus initial position by total time. And an average acceleration is nothing but total change in velocity divided by total time, or final velocity minus initial velocity divided by total time. So out here, average angular acceleration would be, what is the final velocity? Acha, see this equation. I don't neither know the final velocity nor the initial velocity. See, the equation for velocity is omega is equals to a minus 3bt square. or omega is equals to a minus 3bt square. So final would be a minus 3b into what is the time? Time is nothing but a by 3b to the power 1 by 2. That is the time when the particle stops, or a by 3b to the power 1 by 2 whole square. So this 1 by 2 and this whole square would get cancelled. So let's remove this one. Okay. Okay. This b 3 and 3 would get cancelled. Okay. So out here it would be, let's remove this, a minus a. A minus a is nothing but 0. Okay. So average angular acceleration is nothing but a minus a, which is equals to 0. Now the second part of the question, the angular acceleration at the moment when the body stops. So what is the time when the body stops? T is equals to a by 3b to the power 1 by 2. So I find out the equation of velocity. How do I find equation of acceleration from equation of velocity? Yes, acceleration is equals to rate of change of velocity, or alpha is equals to minus 6b t. And what is the time? Time is nothing but alpha is equals to minus 6b into a to the power 3 by b under root. Acha. Can I send this b inside? I'm sending this b inside the square root. So what would it be? It would be b square. Okay. And I'm also sending this 6 inside the under root. What would it be? It would be 6 square. That means 36. Okay. Okay. Now let us evaluate. This b and square would get cancelled. 13 12s are 36. Okay. So let's make it neat and clean. 3b gets cancelled. B square would get cancelled. 36 would become 12. So it would be under root of 12 AB. Under root of 12 AB. This is the answer. This can also be written as 4 into 3 AB, or under root of 4 is 2 AB. Okay. So now let us put the value and give us all the answers. So acceleration, average angular acceleration is equals to 0, and final acceleration is equals to under root of 12 AB. From the previous slide, what did I get? Average angular velocity is equals to 2a by 3. Okay. Average angular acceleration is equals to 0, and acceleration when the particle stop is equals to under root of 12 ab. Acha. Okay. Now let us substitute the values. A is equals to 6 radians per second. So out here, average angular velocity is equals to 2 into 6 by 3, or is equals to 4 radians per second. So average angular velocity is equals to 4 radians per second. Okay. And out here, angular acceleration when the particle stop is equals to minus 2 under root of 12 ab, or is equals to minus under root of 12. What is the value of a? 6. What is the value of b? 2. The value of b is 2. So let us solve it. Alpha is equals to, this can be broken down as, see, 12 can be broken down as 2 into 2 into 3. 6 can be broken down as 3 into 2. Okay. And 2 is remaining. So you get a perfect square, no? So 2 into 3 into 2. So 4, or alpha is equals to minus 2 into 3 into 2, or is equals to minus 12 radians per second square. Okay. Let's look at this question. Okay. A solid body rotating about a stationary axis with an angular acceleration b is equals to 80. Okay. So there is a solid body out here. Okay. It starts rotating about a point with angular acceleration b. Now take any point inside the body which is at a distance r from the axis of rotation. Okay. How will this point move? This point will move in a circular motion, isn't it? Okay. Now let's draw this circular motion out here. This is the axis of rotation. This is the path traced by the point. Okay. Where the body is moving with angular acceleration b. Now say, suppose after the start of motion, the point is somewhere around here. The point is somewhere around here. Okay. What is the velocity vector? V. Okay. Is this velocity vector changing? Yes. Why? Because this body has an angular acceleration. That means the velocity vector out here would keep on changing. Okay. So if velocity vector is out there, that means the velocity is changing. If velocity is changing, there is a acceleration out here. That is called the tangential acceleration. And there is one more acceleration in circular motion. That is the centripetal acceleration. And centripetal acceleration is always required to keep the body in circular motion. Okay. Now see, this centripetal acceleration and tangential acceleration will make a total acceleration. So total acceleration is along this direction. Total acceleration. Now the question is saying, find the time at which the total acceleration makes an angle 60 degree with the velocity vector. That means total acceleration makes 60 degree with the tangential acceleration. Why? Because tangential acceleration and velocity vector are always parallel. Okay, so this is my question. Okay, so my approach should be tan 60 is equals to centripetal acceleration, which is also known as radial acceleration, divided by tangential acceleration, or tan 60 is equals to perpendicular divided by base, or perpendicular divided by base, or centripetal acceleration divided by tangential acceleration. Now my point is, out here angular acceleration is given as a into t. Okay, how do I find out the tangential acceleration from angular acceleration? See, simple enough. There is a relation between rotational circular component and linear component, where acceleration, linear acceleration is equals to angular acceleration into r. Okay, or this linear acceleration out here is nothing but the tangential acceleration out here, is nothing but the tangential acceleration out here. If this body moves with angular acceleration, that will translate to tangential acceleration of this point, no? So this is nothing but the tangential acceleration is equals to beta. What is the value of beta? A into t into r. Okay, so tangential acceleration is equals to atr. Now how do I find out the centripetal acceleration? How do I find out this value, centripetal acceleration? We know that centripetal acceleration is also equals to v square by r, or is equals to omega square r. This is done in class. Okay. Okay. How do I find out the value of omega? See, out here b is given as 80, or angular acceleration is equals to 80. Angular acceleration is also known as rate of change of angular velocity. So if I draw this value, d omega by dt is equals to 80, or omega is equals to 80 square by 2 plus some constant. Okay, so I'm writing this out here. Omega is equals to, not here, let me write it down. Omega is equals to 80 square by 2 plus some constant. Okay, putting the boundary condition at t is equals to 0, omega is equals to 0. How do I know this? See, read the question. A solid body starts rotating. Starts rotating means at initial time t is equals to 0, angular velocity is equals to 0, or linear tangential velocity is also equals to 0. Okay. Okay. So if I put the value of t is equals to 0 out here and omega is equals to 0 out here, I get the value of constant to be 0. So my equation of omega comes out to be 80 square by 2. Okay. So omega is equals to 80 square by 2, or my acceleration comes to be omega square r, or acceleration is equals to 80 square by 2 whole square into r. Why 80 square by 2? Because omega is equals to 80 square by 2, and omega square r is equals to at square by 2 whole square into r, or centripetal acceleration is equals to a square t to the power 4 by 4r. Okay, if I substitute this value ac out here, what do I get? A square t to the power 4 r divided by 4. Okay, now let me write it as tan 60 is equals to a square t to the power 4 r by 4, and tangential acceleration is equals to at r. R and r would get cancelled, t and 4 would get cancelled by 3, a and a square would get cancelled, or tan 60 is equals to at cube by 4. Okay, at cube by 4. What is the value of tan 60? Root 3. Root 3 is equals to at cube by 4. Or 4 into root 3 by a is equals to t cube. Okay, and I can simply write this as t to the power 1 by 3. Okay, and what is the value of a? The value of a is 2 into 10 to the power minus 2. So the value of a out here is nothing but 2 into 10 to the power minus 2. Okay, if I use calculator and solve it out, the approximate value of t comes out to be 7 seconds. Okay, let's look at this question. Okay, a solid body rotates with a deceleration about a stationary axis with angular deceleration beta is equals to under root of omega, where omega is the angular velocity. That means what is happening out here is a solid body out here. Okay, it's rotating with angular velocity w omega, and the angular acceleration is in the direction opposite to the angular velocity. Okay, okay, and beta is directly proportional to under root of omega, or angular acceleration is directly proportional to under root of velocity, or beta is equals to k into under root of omega, where k is the proportionality constant out here, any arbitrary constant, proportionality constant. Okay, okay. Now the question is saying find the mean angular velocity of the body averaged over the whole time of rotation if at the initial moment of time its angular velocity was equals to 0. So what the question is saying is at time t is equals to 0, okay, angular velocity is equals to omega naught, and it was rotating with angular velocity omega naught t is equals to 0, but the angular acceleration was in opposite direction. That means it was trying to, or the acceleration was trying to stop the body from rotating. Okay, okay, and find the average velocity from t is equals to 0 to the time till the body stopped rotating. That means from t is equals to 0, that means find average velocity from t is equals to 0 till the body stopped rotating. Body stopped rotating. That was the meaning of this question. Find the mean angular velocity averaged over the whole time of rotation. Whole time of rotation means till the body rotates, or till the body stops rotation. Okay. Acha. Okay. Now let's simplify this. Beta is k omega to the power 1 by 2. Under root can also be written as k omega to the power 1 by 2. Okay. What can angular acceleration be written as? D omega by dt, or minus d omega by dt. Why minus? Because it is angular deceleration. There is one more formula for deceleration. Minus omega d omega by d theta. And where does this formula come from? Remember the formula, acceleration is equals to v dv by ds along with dv by dt. So this one is nothing but v dv by ds. This one is nothing but dv by dt. Now let me take the first pair of formulas. This formula and this formula. Okay. So a minus omega d omega by d theta is equals to k omega to the power 1 by 2. If I solve this one, Okay, I'm taking this omega down here, or minus omega by omega to the power 1 by 2 into d omega is equals to k d theta. If I solve this, omega divided by omega to the power 1 by 2 is nothing but omega to the power 1 by 2. 1 minus 1 by 2, 1 minus 1 by 2 is nothing but 1 by 2. So it will be omega to the power 1 by 2, and this denominator would get cut. Achha. What is integration of minus omega 1 to the power 1 by 2? Minus omega 1 by 2 plus 1 divided by 1 by 2 plus 1 is equals to k into theta plus some constant. Okay, 1 by 2 plus 1 is nothing but 3 by 2. So this one is 3 by 2. This one is also 3 by 2. Half plus 1 is nothing but 3 by 2. Can I take this 2 to the top hand side? So if I take this 2 to the top hand side, it will become 2 by 3. So 2 by 3 omega to the power 3 by 2. 2 by 3 omega to the power 3 by 2. Okay. Now let me put boundary condition in this equation to find out the value of constant. At theta is equals to 0, that means at the start of rotation, initial moment of time, at the start of rotation, when theta is equals to 0, what was the angular velocity? Omega naught. So theta is equals to 0, omega is equals to omega naught. Now putting these two values out here, what do I get? I get minus 2 by 3 omega naught to the power 3 by 2 is equals to k into 0. K into 0 is nothing but 0 plus some constant. So the value of constant is equals to nothing but minus 2 omega 3 by 2. So value of constant is equals to minus 2 omega 3 by 2. Now can I substitute this constant out here? Why? Because the value of constant is equals to minus 2 by 3 omega naught to the power 3 by 2. So I'm substituting this constant out here. Minus 2 by 3. These are elementary integration, indefinite integral that I'm doing. 3 by 2. Okay. So out here, I can rewrite the equation as, if I take this minus 2 by 3 omega to the left hand side, I can rewrite the equation as 2 by 3 omega naught, 2 by 3 omega naught to the power 3 by 2 minus 2 by 3 omega to the power 3 by 2 is equals to k theta. This is our first equation. Okay. Now the question was saying find average velocity from t is equals to 0 till the time the body stops sleeping. So what is the formula for average angular velocity? What is the formula for average velocity? Total displacement by total time, or final position minus initial position divided by total time. Similarly, what is the value of average angular velocity? Final angular displacement minus initial angular displacement divided by total time, or theta final minus theta initial divided by total time. Problem is, what is theta final? See, theta initial is equals to 0. Okay, because the initial angular position was equals to 0 at the start of rotation. Theta initial out here was taken to be 0. Okay, before the start of rotation, body started moving. Okay, so you can easily take the theta or the initial displacement to be, or initial position to be 0. Okay, problem is, what is theta final? Okay, theta final out here is nothing but, I have to write this theta final in terms of omega. So out here, at final position, what would be the velocity? So you have to find out till the final position, till the final rotation, when the body stops. So at final position, what would be the angular velocity? 0, because the body stopped at final position. So at theta final, the angular velocity would be 0. So if I apply that condition in this equation, at theta final, this omega would be equals to 0. So at theta final, theta becomes theta final, this angular velocity would be equals to 0. So if I substitute this equation, 2 by 3 omega naught to the power 3 by 2 is equals to k into theta final or final angular position, or theta final is equals to, can I send this k to the left hand side? So divided by k. Okay. So out here theta final would be equals to omega to the power 1 by 2. Okay. So theta final is nothing but 2 by 3 omega naught to the power 3 by 2 divided by k. Problem is, what is delta t? Delta t can be written as t final minus t initial similarly. So out here, if I substitute delta t by t final minus t initial, or time final minus time initial. Similarly, what is time initial? At the start of rotation, t is equals to 0. Problem out here is you have to find out the t final out here. What is the final time when the body stops rotating? Okay. I'm taking this entire equation to the left hand side. Remember this equation and this equation. Okay. Now I need to find out the t final. Okay, I found out the theta final from the first equation, from these two equation. Now I have to find out the theta final from these two equation. Or writing the equation as minus d omega by dt is equals to k omega to the power 1 by 2. Okay, 1 by 2, or minus d omega divided by omega to the power 1 by 2 is equals to k dt. What is integration of omega to the power minus 1 by 2? Minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 is equals to kt plus some constant. Okay, minus 1 by 2 plus 1 is nothing but 1 by 2. Out here it is also 1 by 2. Can I send 2 to the top hand side? So if I send 2 to the top hand side, it would become 2. So 2 omega to the power 1 by 2. So nothing but minus 2 omega to the power 1 by 2. Okay. Now applying boundary condition. Why do we apply boundary condition? To find out the value of constant. Okay. At t is equals to 0. At t is equals to 0, omega is equals to omega naught. So if I apply this condition, these two condition out here, so minus 2 omega naught to the power 1 by 2 is equals to k into at t is equals to 0 plus some constant, plus constant. So the value of constant would be what? Minus 2 omega naught to the power 1 by 2. The constant is equals to minus 2 omega to the power 1 by 2. So let's substitute the constant out here. Minus 2 omega naught to the power 1 by 2. Okay, or 2 omega naught to the power 1 by 2 minus 2 omega to the power 1 by 2 is equals to kt. I simply took this part of the equation to the left hand side. Okay, now what was my motive behind this second equation? This is the second equation that I'm obtaining. No, what was the motive behind the second equation? The first equation, that means these two equation, this equation and this equation, the first equation gave us theta f. The second equation, or this part of equation, or equation derived from this and this, would give us tf, or time final, okay. So at in this equation, to find out time final, what is the angular velocity at final time? So at time final, t is equals to tf, angular velocity is equals to 0. Why? Because the body stopped. So if I write 2 omega naught to the power 1 by 2 is equals to k into t final, or t final is equals to 2 omega naught to the power 1 by 2 divided by k. So out here t final is nothing but 2 omega naught to the power 1 by 2 divided by k. So if I solve this equation, average angular velocity is equals to 2 by 3 omega naught by k to the power 3 by 2 divided by time final minus time initial. Or time initial is equals to 0. 2 omega naught to the power 1 by 2 divided by k. Okay. Similarly, k and k would get cancelled, 2 and 2 would get cancelled. So let's simplify it. Cancelling k and k, 2 and 2. Okay, so it's nothing but 1 by 3. Okay, see, out here divided by omega to the power 1 by 2. So I'm writing omega naught to the power 1 by 2. 1 by 2. Okay, now omega naught to the power 3 by 2 minus omega to the naught to the power 1 by 2. So I can do this way. 3 by 2 minus 1 by 2 is equals to 2 by 2, which is equals to 1. Or average angular velocity is equals to how much? Omega naught to the power 3 by 2 is equals to omega naught divided by 3. That is the value of average angular velocity. Let's look at this question. A solid body rotates about an stationary axis so that its angular velocity depends upon the rotation and angle as omega is equals to omega naught minus a phi, where phi is the angular displacement, omega is the angular velocity. Okay, where phi, omega naught and a are the constants. So that means this and these are constant. At t is equals to 0, the angular displacement is equals to 0. That means this is the boundary condition given in the question. Find the time dependence of the rotational angle. That means what the question is saying is find phi with respect to time. So in this equation, is there any parameter of time? So can I express this one with respect to time? No. So the question is saying find phi with respect to time and angular velocity with respect to time. So out here there is a relation between angular velocity and angular displacement. In the question they have asked find the relation between angular displacement and time, angular velocity and time. So we'll proceed with the first one. Omega is equals to omega naught minus a into phi. Okay, what is angular velocity? Rate of change of angular displacement. So d phi by d theta is equals to omega naught minus a into phi. Okay, or d phi by omega naught minus a into phi is equals to dt. Now if I apply integration by substitution, where I substitute omega naught minus a phi to be x. Okay, so therefore dx by d phi would be equals to 0 minus of a. Okay, or d phi would be equals to dx by minus a. Okay, so out here I substitute this entire thing, this to be, or d phi to be how much? Dx by minus a, and this omega naught minus a phi to be x. So minus dx by a and x is equals to dt. Now this can be written as minus 1 by a, where a is a constant, dx by dx by x is equals to dt. Okay, what is the integration of dx by x? Of course it is ln x, or ln x is equals to t plus some constant. Okay, and if we expand the value of x, what was the initial value of x? The value of x was nothing but omega naught minus a into phi. So minus 1 by a ln omega naught minus a into phi is equals to t plus some constant. Now applying boundary condition. What is the boundary condition out here? At t is equals to 0, at t is equals to 0, phi is equals to 0. Okay, at t is equals to 0, phi is equals to 0. So if you apply the boundary condition, minus 1 by a ln omega naught minus a into 0 is equals to 0 plus constant. Okay, this would, a into 0 is nothing but, a into 0 is nothing but constant. So this is nothing but ln omega naught, and this is out here. So the value of constant is nothing but minus 1 by a ln omega naught. Okay, so out here, can I substitute the constant by this value? Of course I can. So I'll substitute the constant with the value of the constant, minus 1 by a ln omega naught. Okay, now let me rewrite the equation. Can I send this to the left hand side? Of course, or 1 by a ln omega naught minus 1 by a ln omega naught minus a phi, okay, is equals to t. This can be written as 1 by a ln a minus ln b, which is equals to ln a by omega naught minus ln a by b, okay, is equals to t. In logarithms, there is a formula: ln a minus ln b is equals to ln a by b, and ln a plus ln b is equals to ln a into b. So out here I simply applied ln a minus ln b is equals to ln a divided by b. Okay, or can I send this a to the right hand side? It would be nothing but a into t, a into t. So if I expand this, ln to the power, so if I put e on both hand side, e, that means e to the power 80, e to the power 80. What would become? The ln would disappear, okay, because e to the power ln to the power anything is nothing but that value. E to the power ln to the power any value is nothing but this value, okay. So e and ln would get cancelled. Okay, now what to do? Now I'm taking this entire term to the right hand side and putting e to the power 80 to the left hand side, or omega naught by e to the power 80 is equals to omega naught minus a into phi. I'm multiplying, or this term e to the power 1 by e to the power 80 can be written as e to the power minus 80, or is equals to omega naught e to the power minus 80 is equals to omega naught minus a phi. Okay, out here, can I take this entire term to the left hand side and this term to the right hand side? Of course, or a phi is equals to omega naught minus omega naught e to the power minus 80. So this equation, when I'm writing out here, so a phi is equals to omega naught, I'm taking as common 1 minus e to the power minus 80, or phi is equals to omega naught by a 1 minus e to the power minus a into t. Okay, so this equation is the function of this equation is the function of angular displacement as a parameter of time, by omega naught by a 1 minus e to the power minus a into t. Okay, now I need to find out the angular velocity with respect to time. Okay, simply what do we do to find out angular velocity? We differentiate this entire term with respect to time. Okay, now I need to find out the part B of the question, that means angular velocity as a function of time. So if I simply differentiate this with respect to time, I get the angular velocity. So d phi by dt is equals to d of, see, this can be written as phi is equals to omega naught by a minus omega naught by a into e to the power minus 80. So d omega naught by a into dt minus d omega naught by a e to the power minus 80 divided by dt. This entire thing is a constant, so this entire differentiated would become 0. So this is nothing but 0. Acha, out here this is constant, and the differentiation of e to the power minus 80 would be minus a dt. So this would become omega naught by a into minus a e to the power minus a into t. Okay, this a and this a would get cancelled. This minus and this minus would become positive. So out here d phi by dt is equals to plus omega naught e to the power minus 80. k, this phi and this minus became positive, this a and this a got cancelled. And what is d phi by dt is nothing but omega. Our angular velocity is equals to omega naught e to the power minus at. Our angular velocity is equals to omega naught e to the power minus a into t.